Good afternoon, everyone. I hope everyone has some full bellies in them. I'll wait for people to get their headsets on. Excellent, I can see all the beautiful light colours shining brightly. Welcome this afternoon. I hope everyone's had a bit of a full stomach now, so they're ready for some more sessions. This is stage 6. A few of the housekeeping rules. First of all, my name's Aaron Peterson. I'm a solution architect here at AWS. I am the host for today. If you've got mobile phones, I'm sure you've heard it all before. Please, can you put them on silent? You probably won't hear them, but the presenter might. We have an app that we've all probably been using. At the end of the session, if you could fill out the survey, there'll be a button inside the session at the end. It kind of comes available at the end. We'd love your feedback. We want to know what's interesting to you so that we can keep improving these things. That will just about be it. Now, this session should be really interesting. If you're building applications and you've got service-to-service communication in a modern architecture, this one's definitely going to be for you. But the twist is we're adding a security element in there, and that should be one of the main focuses. So without further ado, I'd like to bring Mahmoud up to the stage. Mahmoud.
Thank you. Thank you. Hello and welcome everyone. Modern cloud architectures requires a seamless and secure way to interconnect your accounts and your VPCs. VPC Lattice enables zero trust application networking, allowing organizations to build scalable and secure infrastructure with ease. My name is Mahmoud Ismail. I'm a specialist solution architect at AWS, and welcome to the session, Enhancing Cross-VPC Connectivity, Zero Trust Application Networking with VPC Lattice. So for today's agenda, I'll discuss how you can connect your services and your resources using VPC Lattice. I'll then talk about security, access control, and with Zero Trust. I'll then talk about observability. So in an organization, we typically see two types of personas. The first persona is the cloud admin or the platform engineer. This person is responsible for accounts, VPCs, interconnecting these VPCs, security guardrails, landing zones, telemetry, things of that nature, things that are infrastructure related. The other persona is the developer persona. So they're more concerned with defining a service, exposing that service for other clients to consume, but also providing access control for the service. What we see typically, and it's kind of well known, that developers don't really want to be boiled down with the, with the networking stuff, with the infrastructure stuff. They just want it kind of to work, right? And so, how many developers here in the room that love networking? This is going to be, how much would you like to see this simplified, right? It'd be much easier. So I want to take you through two connectivity models. The first one is network-to-network connectivity, which is connecting at layer 3. Let's say you have a client VPC and you want to interconnect to an application VPC to access some resources. First thing you need to do is create the networking pipe between those two VPCs. And the more VPCs you have, the more you have to consider what to do with that networking pipe. And you have to think about how you do your routing configurations and your route tables and all of that good stuff, right? Now, the enabling service for this are things like Transit Gateway, Cloud WAN, VPC peering. But when you do this and you construct these, these network constructs, you need to think about security and how to secure the perimeter. So you start thinking about inspection architectures and firewalls and introducing them into your infrastructure. And then you have to, we all know NACLs and security groups, and you probably used them in the past, but we're securing the perimeter here at the network boundary. The second model is application networking. In this model, we're operating at the application layer, at layer 7. So we're basically doing routing here with path-based or host-based routing. Now, what we're doing here is we're taking the application and the application VPC and bringing them closer and representing them to the client directly as if you're connecting to them locally. The enabling services for this is VPC Lattice and Private Link. And now with this infrastructure, we have a defense in depth layer you could add, which is authentication and authorization. This is the zero trust component of these services, along with the security, the network-centric constructs like access lists and security groups. And that's the whole purpose of VPC Lattice. Basically there to simplify application networking for you and bridging the gap between admins and developers. There are three pillars I'd like to take you through today: connectivity, security, and observability. So how can VPC Lattice help with connectivity? Let's say we have some clients that live in a client VPC and you want to connect to some resources and some workloads that live in another VPC somewhere else. The first thing you would do is you set up a Lattice service network. A Lattice service network is a logical abstraction, basically, that when you associate your clients to the service network, through the service network, you'll be able to connect to your resources on the far end. So the first thing you do for layer 7 applications, you create a Lattice service. This Lattice service is associated with this service network. And now you can connect to your service at layer 7. In a similar way, for TCP resources at layer 4, you create resource configurations which represent your resource. And it's this resource configuration that you associate with the service network. And now you have a path on the provider side providing some kind of service through the service network. And after this, the next step to do is to connect the clients and associate that to the service network. Thus, what you're doing here is creating an end-to-end networking flow between the provider side, between the client side, initiating the connections, to the provider side, where all your services and your resources are being held. So let's talk about the provider side. Let's start with the provider side first and talk about layer 7 services and connecting them through Lattice service. So with this, you create a Lattice service which basically provides you a DNS entry point to your service. This DNS entry point basically is how your clients will consume your service on the front end, irrespective of what compute type you use on your back end. So you can be using EKS, ECS, EC2, or Lambda. It doesn't really matter. It's to the discretion of the service owner or the developer to build the service however they want. And if you have a microservices architecture, you could build multiple of these services out, right? And each service will have a DNS entry point. And the flexibility here for each of the service owners is kind of great here because you're free to do whatever you want and experiment with anything you want. You could provide the routing that you like. You could set up blue-green deployments. You could even do cluster upgrades. All of this, and the client won't even know what you're doing. All they're seeing is connecting to this entry point, and that's all they're seeing. So from the service owner or the developer perspective, you are allowing a network path through, and you're not even set up a single routing table at all. So the routing concept here kind of goes away. Staying on the provider side still, now we want to connect to layer 4 services, TCP resource. What you'll do here is you'll create a resource gateway. This resource gateway acts as the ingress point to your resource that you want to share. Okay, so this is the network path through that VPC to your resource. Now that resource, you configure a resource configuration, which is a logical representation of your resource, and this resource configuration is shared or associated with that service network. This resource can be either an EC2 instance, it could be a cluster, like think of Kafka cluster, Elastic Cache cluster, it doesn't matter. It can be an RDS instance as well. So whatever resource you want people to connect through, your clients to connect to, through that service network, you just create a resource configuration representing that resource, and you're associating that with the service network. The resource doesn't have to be within the VPC itself. It could also live on your on-premises network, and it can be represented through this resource configuration. So through the service network, you could connect to on-prem. And if you need load balancing, you could share the resource configuration as the NLB, either the IP address or the DNS, as the resource. You could also connect to a resource in a different VPC as well. So let's say there's a particular account or a VPC that wants to share across the service network that clients need to connect to. You can now connect through a layer 3 network, transit gateway or cloud WAN or VPC peering, to that VPC, to that resource in question. you could also connect out to the internet. A URL can be represented as a resource within the service network as well. So this was all on the provider side. To recap that, you have layer 7 services that you share and associate to the service network as a service association. So you're able to connect your services at layer 7. And then you could also connect your layer 4 services, your TCP resources, to this service network as well. And this opens up many use cases in terms of how you want to connect, where the resources are. You can connect them out to on-premises, to another VPC, or as connect to a URL out to the internet as well. So what I've discussed so far is the provider side. You shared now some services and resources to the service network. We need to now connect to those resources through that service network. So let's go to the consumer side. How do clients actually connect? There are 3 ways to connect. The first one is network association, and the other 2 is through endpoints that I'll get into more detail in the following slide. So the first way, the first option, is service network association. Basically, this association means that only this VPC and the clients in this VPC can access the service network and the services that have been shared with it. Only this VPC, meaning it does not have any routable IP address. The ENI that gets created as part of the service network gets put into the VPC, which is non-routable, meaning you cannot transit through these VPCs to connect to the service network because they're non-routable. And just to iterate here, this will give you a connection to many services and resources. As long as you share them to the service network, those VPCs will have access to those resources. Now, the second option is to actually put a endpoint, a service network endpoint into that VPC. What that does, it creates a routable IP address, meaning you can now transit through from other networks, from your on-premises network or other VPCs, through these VPCs, through that endpoint, and to those services that you've shared to that service network, right? So the main difference between this option and the previous option, in the previous option you could only associate one VPC, and only that VPC will have a connection. But in this model, through that endpoint, you can connect many networks through that endpoint. The last option, actually just to stay on the service network endpoint type, you could have multiple service networks that you want to connect to. Let's say in a multi-tenant architecture, one endpoint will connect you to a service network, and another endpoint will connect you to another. So if you're like a multi-tenanted service provider and you want to provide access to multiple service networks, what you'll do is you'll create one service network and that will connect you to one endpoint, and that will connect you to one service network. Okay, so that was the 2 options that we saw. The third one is a resource endpoint. A resource endpoint is an endpoint that gets put into your VPC as well, but does not use the service network to connect to your resources, right? It doesn't use the service network. So it's great for simple deployments, right? Where you just want to connect one endpoint to one resource. The problem becomes if you have multiple resources you want to connect to. So let's say you have 50 resources you want to connect to, you need 50 resource endpoints to connect to them. The more efficient way to do this is to create one service network endpoint, which is the option I mentioned earlier, and that one endpoint will connect you to many services and resources, like one-to-many. Where in this model, it's one-to-one. That's the key difference here. So if you have a requirement just to do a simple deployment, just there's one resource you want to connect to, this is a great model to use. So let's recap the consumer side now. So we finished with the provider side. The provider, we are exposing layer 7 services and layer 4 resources. All good. They're all in the service network. So the first option we talked about is the service network association, meaning there's no endpoint. You can see in that diagram, it doesn't have an endpoint. So it's only that VPC that has access to that service network. Second option is you put a service network endpoint, which is a routable IP address, And the last way is the resource endpoint, which gives you a one-to-one mapping to a resource. Now, in terms of who can connect through these networks, through these VPCs, it's only to the ones that have routable IP addresses, which is the service network endpoint and the resource endpoint. The network association will not be able to act as a transit here. Cool. So looking back at the persona problem that I mentioned earlier, in terms of handling cross-VPC connectivity in an easy way without even doing routing tables, VPC Lattice is a great option here. I just discussed how you can connect your clients to the resources they need to connect to without setting up a single routing table here. And this is the power of the service network and VPC Lattice. And you don't need any network expertise here. So it kind of ticks the box for both personas. Okay, so let's move on to security, the second pillar. So how do we kind of protect or give security to our cloud infrastructure? The first way is identity-centric. Identity-centric meaning we're more focused on the identity, like who or what is able, who is requesting the access, who can have access, right, to the identity level. The second way is the network-centric way. So network-centric is more tied with network boundaries and really relies on protecting the network itself. So it's really heavily tied to network boundaries. The best security is when you actually combine these two together, right? When you combine them together in your environment. And this is what Zero Trust is. Zero Trust doesn't rely solely on perimeter network controls, but also has a defensive depth concept of putting identity access control as an extra layer. So what does defensive depth with Lattice look like? The first layer is through association, right? So if you're not associating your VPCs or your service to the service network, you haven't established a network path, right? So there's no way for one to connect to the other. So that's the first layer, to actually make the connection happen. If you do have the connection happen and you've established the path, how do you start restricting access now? The second layer is through security protection, through like access lists and security groups, network-centric security constructs that we all kind of worked with in the past. The third layer with VPC Lattice is auth policies, Lattice auth policies, which is basically a way to provide IAM-based policies to your service networks and your services as well, which I'll go into deeper in a second. So let's start with the network-centric approach. How do we secure our infrastructure and our environment with security groups? You set your boundaries, right? So we have to define the security groups in such a way that we're only allowing the certain clients access to the service network through security groups. That's on the consumer side. Now on the provider side, for resources, you only allow access from the resource gateway because that's your ingress path to your resource. So by defining security groups on the resource gateway and saying I only allow traffic from this resource gateway, effectively what you're saying is no one can access this resource except if you're coming from the service network. And from a Lattice perspective, from a service perspective, for layer 7, if you want to put security groups, the security groups can say only allow traffic from Lattice prefixes. So we've got set defined prefix list for Lattice. All you got to just make mention of that in your security groups and allow it. So this is security groups. You can see you have its boundaries, right? Network boundaries. Where if we do identity-centric, we look at IAM-based policies here for your auth policies at the service network level and the service level. In order to make use of this, you need to sign your request with SIG v4. So from the client side, we have SDKs and all this to make that happen. You sign the request and you'll be able to get authenticated and authorized in VPC Lattice. So I said that you can apply the auth policies at the service network level and the service level. So at the service network level, that could be under the administration of the cloud admin to say, I'm only allowing particular maybe principal or a particular organization to access this service network. So this is what we call coarse-grained access policy, right? Then, moving down to the service level, this is where the service owner now can be a bit more granular and provide finer and more granular rules that can dictate who can speak to their service. And this is where the zero trust comes in, right? Here you're actually basing it on identity to say a certain service or a certain principal or a certain client can invoke my service to hit this particular resource. And if you're a service owner that has many resources, you can be granular and say which resources you want them to have access to, right? And even the request method, whether it's a GET or a POST, it is very granular here. And we're putting the security access control into the hands of the service owners and the developers here to give an extra layer of defense. So how does this look like? If you have allowed your auth policy at the service network level and the service level, overall, this request is allowed. But at any stage, if one of them is not allowed, so the service network might be allowing something, but you as a service can be granted, no, I don't want these connections to come through. The overall request here is denied. And this is what I mean by zero trust here. It's all identity based. And in terms of personas, this is what I just mentioned moments ago. The cloud admin or the platform team can be responsible for the service network auth policy, and they could be responsible for setting up the service network as a whole. That service network could be a construct that lives in your networking account. I'm sure you have probably a landing zone somewhere with a networking account that has transit gateways in there. This is very similar. So you create your service network by the cloud team, they put that in a networking account, and they're free to share that to all, to the services, and the services can actually associate their services with this service network now. So there's a clear separation of roles here. Cool, so going back to the persona problem, in terms of security guardrails and enforcing at a more network level, for the whole organization, the cloud admin can do that. But if you want to get more fine-grained, the developer or the service owner can put zero trust principles into their service as well. All right, observability. Access logs. So with Transit Gateway, or if you're using VPC peering or VPC flow logs, we're operating at layer 4, right? So in terms of metadata, all you have access for is layer 4 flow logs, right? For Lattice, service network, and services, we go up the stack here, right? So you actually have more insight into your requests and into your response. So here you can see that the host header is example.com. You can see the method that was used, and you can see the path as well, right? So from a tracing perspective, this is inbuilt as access logs into Lattice itself. Well, there's actually more stuff you can do. You could actually see the path as well. You could see the calling VPC, right? You could actually see the calling identity. You can see the target service that it was meant to hit, right? You can see the service network. So you can see all of this in the access logs as well. And on top of that, you could also see how long a request actually took in milliseconds. So in this example, you got 375 milliseconds. With Transit Gateway, you got to put the tracing on the sides, right? You got to put that on the edges to get all that telemetry, right? This is inbuilt already in VPC Lattice. But yeah, I'll go to the next slide here. So the next one is metrics, right? So this is data points from service network and service to help you monitor in real time, to troubleshooting and monitor the performance of your service. And this is very similar to what you've seen like in ELB, right? Error count, request count, timeouts, the codes, this is all available to you as well through Lattice. For access logs for resources, because we're operating a layer 4 here, you don't obviously get to see sort of the request header and the up the stack kind of detail, right? You see much more like a flow log, but at least it's all in one central place. You get some really good insights here as well. So that completes all of the problems here in terms of what the persona problems were, right? They could use advanced telemetry at the service level. So every service owner can now see how long a particular request took for their service, right? They'll have access to those logs and those metrics, and they could decide on how to better improve their performance of their service as well. And this is done on a per service level. So to summarize, you could use application networking is a networking model in which you really don't need to worry about network routing and complex many-to-many VPC interconnects through some routing tables, right? It's as simple as taking the concepts of application networking, creating your service, exposing your service for other clients and consumers to take on your service, right? To consume your service. And while doing so, you could apply identity access controls to define who can have access to your service. And there's a role of separation here where the cloud admin can put a level of security, and the service team or the service owners can actually define what zero trust means to them and define the auth policy there. And also, as we saw earlier with the metadata, you don't need to put tracing in your environment to say how long things are taking. This is inherent in VPC Lattice. We can see how long how long a request took, how much bytes have been sent, and you can send that to something like Grafana or CloudWatch. You could start seeing how much traffic is being pushed through, all kind of stuff. Cool. I'd like to thank you for your time. Yeah, if you have any questions, I'll be hanging around as well. Thank you all. Thank you so much.
Thank you very much, Mahmoud.